Hello, welcome to the first unit of probability. This is chapter 9 in our book. Today we're going to study the terms associated with probability, and then we will learn a little bit about how to count events. First, here's some terms for random experiments. A trial is the thing that you're doing. So if we're going to throw the dice or drawing a card, we call that a trial. An outcome is the result from your trial. So the result from throwing in a dice. So the outcome might be 6 and a 1. An event is something that occurs from the outcome. So I might want to look for the probability that my dice will equal 7. So the probability that when I roll 2 dice it equals 7, this x equals 7, that's going to be an event. Or we could say the probability that we roll an even number for a sum. So you can have many different events for a specific trial or outcome. A sample space is the set of all outcomes in an experiment. So everything that can possibly happen is in the sample space. So all the possibilities that can occur from rolling 2 dice. Well, on the first die, you can roll 1, 2, 3, 4, 5, and 6. And on the second die, I should say, you can get the same things. So our sample space would be 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. And over here, it'd be 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Now, hopefully filling in the rest of this is just pretty easy. It doesn't take a lot of thinking. You just fill in all of the different possibilities. So when we're done, we should have 6 times 6, or 36 different outcomes. This specific sample space is really important for a lot of probability questions, because a lot of probability comes back to dice. Also, a lot of probability goes to cards, and we'll talk about that in a little bit. Just after I'm done finishing this, I should have done this ahead of time, so you didn't have to listen to me mumble my way through this. All right, there you go. So here are the 36 different outcomes. Notice 2, 1 and 1, 2 are 2 completely different outcomes. There's only one outcome for 1, 1. To find out how many ways you can get 4, it would go in a diagonal this way. So there's 1, 2, 3 different ways out of 36 that you can get 4. To get 7, it would be 1, 2, 3, 4, 5, 6. 6 out of 36. So the sums are all on the diagonals. So if I want to find the probability of something occurring, we take the probability of an event over probability of the number of events in the sample space. This is where counting is very important. You have to know how to count the elements in the event and how to count the number of elements in the sample space. So let's take an event probability. I roll the sum is 3 when I roll 2 dice. The sum is 3, it happens here, and it happens here. So that will occur 2 times out of 36, which would be 1/18. So that would be the probability that the sum is 3. Now, if we were in class, I would have you do numbers 1 and 2 from the textbook. It's section 9.2. But we'll just take a second and do that. Number 1 says, a card is drawn at random from a standard 52 card deck. What's the term used in probability for the act of drawing a card? And that is a trial. How many outcomes are there in the sample space? Well, we're just drawing a card at random, so there's going to be 52 different outcomes because we're just drawing one card. How many outcomes are there in the event the card is a face card? Well, there's 3 face cards, Jack, Queen, and King in each suit, and there's 4 suits. So there's 12 face cards. If I wanted to find the probability that the card is a face card, well, there are 12 face cards in a deck of 52 cards. So 12 52seconds, which could go down to 6 26ths, which can go down to 3 13ths, which really makes sense because there's 13 cards in the suit, and 3 of them are face cards. The probability card is black. There's 26 cards that are black out of 52, which can reduce to 1/2. I think that's all I got on this page. Yep. Now, if I want to find the probability that the card is an ace, there are 4 aces out of 52. That will reduce to 1/13. What's the probability that the card is between 3 and 7 inclusive? Inclusive means that it includes the 3 and the 7. Well, there's 3, 4, 5, 6, and 7. That's 5 different cards per suit. So we could think about this 2 different ways. Since it's 5 cards per suit, we could say that it's 5 out of 13. Or we could take that 5 and multiply it by 4, and then it would be 20 52seconds, which would then, again, simplify down to 5/13. What's the probability the card is the ace of clubs? Well, there's only 1 ace of clubs out of 52 cards. What's the probability that the card belongs to the deck? Well, it's going to be 52 cards are in the deck out of 52 cards, so that's just going to equal 1. What's the probability that the card is a joker? Well, if it's a standard 52 card deck, it's going to be 0 out of 52, which is just 0. Alright, now notice that these are all different events. The probabilities of the events are much different depending on what the event is. The second one, a penny, a nickel, and a dime are flipped at the same time. Each coin can either land heads up or tails up. What's the term for flipping a coin? That's a trial. What are the one possible outcome is tails, heads, tails. List all 8 possible outcomes. So they give us a start there. Alright, these are all 8 possible outcomes. How many outcomes are in the event exactly 2 coins show heads? Well, let's look. 2 coins show heads. Well, there's 1, 2, 3, 4. So how many outcomes are there? Oh, exactly 2 cards. So exactly 2 would be 1, 2, 3. So that would just be 3. I thought it said at least. What's the probability of heads, heads, tails? Well, heads, heads, tails happens once out of all 8 times. So that would be 1 out of 8. What's the probability of at least 2 heads? Well, I already counted that up, and that was 4 out of 8, so that's 1/2. The probability of the penny and the nickel are tails. So let's look back at this problem. The penny and nickel are the first 2, so the probability of the penny and the nickel are tails. That happens once, twice, out of all of them, so that would be 2 out of 8, or 1/4. What's the probability the penny or the nickel is tails? That's different. So here the penny is tails, so check, 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 These ones are both heads, so that doesn't work. And then there, the nickels are both tails, so that's 6 out of 8. So there's a 6 out of 8 chance, or 3/4. That's a penny or nickel is tails. Now notice the difference between an and an or. If it's and, it's 1/4. If it's or, it's 3/4. What's the probability that none are tails? Well, that only occurs when it's HHH, so that would only happen once out of the 8 times. What's the probability we have 0, 1, 2, or 3 heads? That would be 8 out of 8, which is 1. And what's the probability you get 4 heads? 0, because you're only doing it flipping it 3 times. Alright, now to use the definition, all outcomes must be equally likely. On the spinner below, there are 2 outcomes, gray and white. Using the formula, the probability that you get white is 1/2. Is that true? Hopefully everybody says no, that's not true. And let's think about how we can number this. We could say the entire sample size is 360 degrees. Or since this divides up evenly, we could say divide this into 4 chunks and say that the sample size is 4. Now, if I said that the sample size was 360 degrees, then the white would be 270 degrees. If I said that it was 4, dividing into 4 sections, then 3 of them would be white. So in either case, the probability of being white is 270 over 360, which is 3/4. So say we eat at Chipotle. At Chipotle, you have to choose a meat. How to eat your food and then a type of meat. So you have an entree, so burrito bowl tacos, or salad, and then you have a type of meat. How many different ways can you choose a meal with one type of meat? There's 4 here, so if I could do burrito chicken, burrito steak, burrito barbacoa, and so on. So there's 5 for burrito, 5 for burrito bowl, 5 for tacos, and 5 for salad. So 5 plus 5 plus 5 plus 5, or 4 times 5, would just get you 20. So there's 20 different ways. How many ways can you choose 2 types of meat? If I'm just looking at the meat, how many different ways can I choose 2 types of meat? Well, we could do chicken and steak, chicken and barbacoa, chicken and vegetarian, and then chicken and carnitas. Then we could do steak and barbacoa, steak and vegetarian, and steak and carnitas. Then we could do barbacoa and vegetarian, barbacoa and carnitas, and then we could, last one would be vegetarian and carnitas. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 different ways we can choose 2 types of meat. How many different ways can you choose how to eat your meal and 2 different types of meat? Well, there's 10 different ways we can do 2 types of meat. So 4 times 10, that would give us 40. So there's 40 ways we can choose 2 types of meat, but only 20 ways we can choose 1 type of meat. Alright, there are 12 AP statistics students after school and 3 squeeze students after school. If they are coming and all waiting patiently for me to help them with their homework, how many ways can I pick my first student to work with to be an AP statistics student, and the second person I work with to be a squeeze student? Well, there's 2 blanks. The first blank, I have 12 different choices. My second one, there's 3 choices. So there would be 36 total choices on how I could pick the students. How many ways can I pick my first student to be an AP statistics student or a squeeze student? So I'm just picking one student, and it's either AP statistics or squeeze. I would have 15 different choices. How many ways can I pick my first student to work with to be AP stat student, and the second person I work with to be an AP stat student? So there's 12 ways I can pick my first student. And now my second student, there'll only be 11 ways because I've already worked with one student. So that would be 12 times 11, which is 132. If you draw one card from a standard deck of 52 cards, how many ways can you choose a heart or a face card? Well, first, let's just think about how many ways we can choose a heart. There are 13 cards in a deck. How many ways can we choose a face card? There are 3 of them in a deck. Oh, no, face cards, there's actually 3 times 4, which is 12. How many ways can I choose a heart or a face card? Now, a heart or a face card means a card that I choose can either be a heart or a face card for this to be true. So we could say we take all of the hearts, which is 13, and add the face cards from the other 3 suits. So we have the hearts, there will be 13, and then let's say this is new face cards. There will be 9 face cards outside of the hearts. So if we add those two together, that will be 22 cards. Another way we can do it is add these two numbers up and subtract out the number that they have in common, which is 3. So that would be 25 minus 3, which again would give us 22. Now if I said what's the probability of a heart and a face card, how much do these things have in common? Just 3. So again, notice the problem is much different if it's an and than if it's an or. Now we'll learn about the term mutually exclusive. Mutually exclusive means 2 sets that don't have anything in common. Say a boy and a girl. Those are 2 different sets. So we have a boy and we have a girl, and there's nothing that is in common of those. No person will be in both of those categories. An even or a 6. So if I have my evens, and if I have a 6, that has to be inside of here. So this is not mutually exclusive. This is mutually exclusive. An even or a 5, that would be mutually exclusive. I'm just going to write ME up there. A club or a face card, those things are not mutually exclusive because you could have a club and a face card. A club and a red card, this would be mutually exclusive because those are 2 different sets. A boy or a soccer player, that would be not mutually exclusive because you can't have boy soccer players. Annie loves to travel. She traveled to 9 different island nations in Asia and has been to 5 different tropical island nations. She has been to 3 different Asian island nations. How many island nations did she visit outside of Asia? Now these types of questions are easily answered with a Venn diagram. Now, some people can just look at them and see the answers, and these are going to get more complicated, so I just want to show you how the Venn diagram helps with these problems. So if this is Asian nations that she's traveled to, and this is islands, this entire circle has to add up to 5. This entire circle has to add up to 9. And the thing that's overlapping in them is right here, 3. So if that's 3, then that means there's 6 nations that she went to in Asia that weren't island nations. And this whole circle has to add up to 5, so that there are 2 islands that were not Asian nations that she went to. So in total, or here it says how many island nations did she travel to outside of Asia? She went to 2 nations outside of Asia. How many island nations or Asian nations did she visit? Now to do that, we have to add up all of these numbers. So it would be 9 plus 2, which would be 11 nations. Alright, here's another type of problem. A senior class has 240 girls, 328 own a car. All right. Um, so how many ways can you select a girl or a student who owns a car from the senior class? So let's set up our Venn diagram. We have people who own a car, and we have girls. Of the girls, 60% own a car. So 60% of the girls. So 250 times 0.6. I actually don't have a calculator right now, so I should I have to do this by hand. Isn't too tough. 150. So there's 150 girls that own a car. So that means this whole circle has to add up to 250. There's 100 girls who don't own a car. And if there's 328 students that own a car, so we have to take 328 minus 150, and that is going to be 178 students that own a car that are not girls. So there's 178 male students that own a car and 150 female students that own a car. So how many different ways could you select a girl or a student that owns a car? So if I add up all those numbers, that'll be 150, 250, and 178. So there's 428 ways that you can pick either a student that's a girl or someone that owns a car. Now, when 10-digit numbers were introduced in the United States and Canada during the 1960s, there were certain restrictions placed on those numbers. The area code had to be 3 digits. The first must not be a 0 or a 1, and the second must be a 0 or a 1. The exchange code is 3 digits. The first and the second must not be a 0 or a 1. And the line number was 4 digits, where there's at least one, but that must not be a 0. Find all the possible area codes. So we have 3 places here. The first one must not be a 0 or a 1. So there's 8 choices for our first digit. The second must be a 0 or 1, so there's only 2 choices for our second digit. But our third could be anything, so that means there's 10 things that it could be. So 8 times 2 is 16. 16 times 10 is 160. How many possible exchange codes? Well, the first and the second must not be a 1 or a 0. So that would be 8 and then 8. And then the last one could be anything, so there's 10 options for the last digit. So 8 times 8 is 64. 64 times 10 is 640. So there's 640 different exchange codes. How many possible line numbers? Well, at least one must not be a 0. So let's find all of them. So there would be 10, 10, 10, 10. But we would have to subtract 1, because the only case where this is true, this is just saying you can't have it 0, 0, 0, 0. So it's only one way that we have to just subtract from that. So that would be 100, 1,000, 10,000. 10,000 minus 1 would be 9,999. Finally, find the total number of phone numbers that are available in this format. Now what we have to do is multiply 160 times 640 times 9,999, and we'll get our correct answer. I might go get a calculator for this. All right, the correct answer was 10238976600. If I throw in my commas, that's 1,000, million, billion. So there's over 1,023,897,600 different numbers using this format. Now, how many 10-digit phone numbers are possible with no restrictions? So that would be 10 times 10 times 10, so it would be 10 to the 10th. So that means it's 10 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put my commas in. Thousands, million, billions. So there would be 10 billion with no restrictions. So the restrictions cut down quite a bit from 10 billion to 1 billion. All right. Hopefully that's enough to get you through your homework. Good luck.